In this lesson, we're covering two concepts. The first is the idea of cofunctions, how sine and cosine are cofunctions, and then getting into using our inverse trig, solving for missing angle measures of right triangles. So we were going to use these first three questions as a review. So I would say go ahead and pause the video. Using this right triangle here, PKR, go ahead and do these three questions, and then we'll discuss and go over, and then we'll talk about the cofunctions. And here we go. So the ratio that represents sine of P. So here is P. So sine, remember, right, is opposite over the hypotenuse. So opposite is 6, hypotenuse is 10. So 6 over 10. Then, of course, you could simplify this to 3/5. Then the ratio that represented cosine of R. Well, the cosine of R is, well, cosine is adjacent and hypotenuse. So here you've got the adjacent, which is now 6 over 10, or again, 3/5. So now what do you notice about the two ratios that represent the sine of P and cosine of R? They are the same. They are equal to each other. So then how do you think that the ratio representing cosine of P is now going to be representing compared to the ratio representing sine of R? Well, again, these two are going to be equal to each other. And then if you wanted to double check, cosine of P is 8 over 10, and sine of R is 8 over 10. So that's what we mean by these cofunctions. So here, if we were to switch the angles and you get the sine and cosine, they are going to be the same. And then thinking about it in angle measures, these cofunctions. So here, just to erase so that we can write in. So let's say angle P now is 35 degrees. Then the measure of angle R has to be what? 55 degrees, right? Why? Well, because we already have a 90 degree, and that will always be there, right? Because of the right triangle. That means angles P and R always have to add up to 90 degrees. They are complementary. So that means here that, so if I wanted to put it in relation of the angle, that sine of 35 degrees, sine of P, was equal to cosine of R, which was 55 degrees. So notice how here the angle measures are not the same, right? The cofunctions show that they are complementary. So that's how they're equal to each other. So if we wanted to write this out mathematically, the sine of theta, our angle measure, so this is our angle here, is going to equal not cosine of theta, but cosine of 90 minus theta, right? Because here in the end, 90 minus the angle, let's say was 35, gave you 55. And same thing for cosine. So this is equal to sine of not theta, but 90 minus the angle measured given to us. So again, this is our cofunction relationship, keeping in mind that they are complementary. So like here, and this is just to show you now with the variable, x, same thing. So if I wanted to write sine of 28 degrees in terms of cosine, so if I have sine of 28 degrees, so here, let's say one angle is 28 degrees, then that's the same as getting that cosine of 50, not 52, sorry about that, of 62 degrees. So again, that's how we write sine of 28 in the form of cosine. So again, here, how do we write cosine of 36 degrees in terms of sine? So this is not sine of 36 degrees, right? Sine of 90 minus 36, which is 54 degrees. So go ahead, and I know it says examples, but since we just talked about this, go ahead and pause the video and go ahead and do A and B. And if you want to try C, go ahead and try C. We will go over D though in this video. And here we go. So for the first one, you should have said that the value of theta is not 25 degrees, right? Because they're cofunctions, but 65 degrees. So then same thing here, theta is equal to 10 degrees. Now here, little different, right? Because we're thinking what value of theta, where these two would be the complementary, showing the cofunction. So like, let's say, for example, you said theta was 30. So this is 30, then this is 30 plus 10, which is 40. So that only adds up to 70. So you should have seen that theta is equal to 40 because this here is just 40, and then 40 plus 10 is 50. 40 and 50 are your complementary. Now, just to show you how we could also set this up as an equation if you wanted to solve. Again, what is the relation with our cofunction? The two angles are complementary, right? They add up to 90. So that means that these two angles added together equal 90. That is your equation. Theta plus theta is 2 theta plus 10 is equal to 90. And then notice you're just solving a two-step. Now, if you wanted to, you could replace theta with x. It's like a variable, right? Where you would just subtract 10 from both sides. You've got 2 theta is equal to 80, divide by 2, and there's your theta is equal to 40. So using the same concept here, right? These two cofunctions add up to equal 90 degrees. So again, 6 theta plus 5 is equal to 90. And now you're just solving a two-step. Where here we would subtract 5, and you've got 6 theta is equal to 85. Then here, divide by 6, and you get that theta is going to be approximately 14.16 repeating. So again, go ahead and pause the video and try these two U-tries here on your own. And here we go. So here you should have just said that theta is equal to, not 28, right, but 62. Here you could have done the mental or set this up algebraically. 2 theta plus 20 is equal to 90. So you should have gotten that theta was 35. Then of course you can check, right? I've got cosine of 35. 35 plus 20 is 55. And these two are complementary angles. With these last two questions talking about the cofunctions, so setting it up a little different here with the wording of the questions, if you wanted to go through and try these two on your own, I would say go ahead and pause the video now, and then we'll go over these two questions. And here we go. So sine of A is 0.6 and cosine of A is 0.8. So notice how we're talking about the same angle here. So if you wanted to see this visually for the explanation, we're saying, like, let's say this is A, B, and C. We're saying that sine of A is, so 0.6, and we'll say here, so we're going to get 1 or 0.1. Oh no, not 0.1, sorry about that. That would be here, would 1, and 0.8. So again, notice the visual, how we're with just A here. So sine is opposite, so 0.6. Cosine is adjacent, so that's why it's 0.8. So here, determine the values of sine of B and cosine of B. So notice how here, what you should have done is not keep them the same, right? Because now we're changing our angle here. So A is not it. Also, technically B, well, that's working like with the hypotenuse, a different value. That's why here the answer is C. Because if sine of A is 0.6 and cosine of A is 0.8, that means sine of A, which is 0.6, is the same as cosine of B, which is 0.6 as well. Because again, here, it's going to be the complementary angles that have the same value. So that's why here, cosine of B is 0.6 and sine of B is 0.8. And then this one here, you just have to remember, if sine of X is 1/3, then what other value is going to also be 1/3? Well, the complementary. That's why the answer is D, because here's showing your complementary. So now we're going to get into our inverse trig, where we are still going to focus on our SOHCAHTOA and identifying the missing angle measure now, because notice how we're given 2 side lengths. We're not looking for the third. We're looking for the measure of angle R here first. So notice the relation. Well, first off, do we have the hypotenuse? Yes, 5.7. Notice how it's opposite from your 90. With a hypotenuse, notice how 5 is adjacent to angle R. So in this case, we're going to do cosine, but of angle R, right? Because we don't know what angle R is. That's what we're looking for. That is equal to 5 divided by 5.7, 5 to 5.7. So our adjacent over hypotenuse, right? That is your ratio here. So now how do we find cosine of R? This is not like a dividing, right? So to inverse, that is where your inverse cosine, make sure to locate this button on the calculator, which is above your cosine button. So you'll have to second or shift to be able to put this in your calculator. So I would say pause the video, try to locate this, put this in the calculator, make sure that you're in degree mode, and let's see what you get that the angle R is approximately. And here we go. You should have gotten approximately 28.7 degrees. So just to practice, we'll also calculate angle T. Now keep in mind, angle R and T are complementary, right? That's what we just talked about, how you have the 90 degrees. So that means technically we should get that T is approximately 61.3 degrees, right? From subtracting from 90. So let's try it. Angle T. Well, now notice what's the relation with 5 here? It's opposite. So that's why we would use sine of T is equal to 5 over 5.7, which again, now you take the inverse sine. When you put this in the calculator, you should get approximately 61.3 degrees. So make sure you practice putting that in. So now again, let's make sure that we're good, right? We're going to find the measure of angle F. So here's angle F. Do we have the hypotenuse? No. Notice how completely empty. So we are going to use tangent to find the measure of angle F. Now let's set up our ratio. Opposite over adjacent. What is opposite from angle F? 4. What is adjacent? Connected. 8.2. So now we can go through and take inverse tangent of our ratio here. So again, practice putting that in your calculator, and you should get approximately 26 degrees. Go ahead and pause the video now and try the U-try on your own, finding the measure of angle C here. And here we go. So again, you should have noticed no hypotenuse, so you should have used tangent of C, which is equal to opposite is 100 divided over 7, your adjacent. So when you find the inverse tangent of this ratio here, you should have gotten that C is approximately 86 degrees. So again, focusing on that angle relation, however, you could have angle of elevation where that's looking up from a horizontal line here. So just to kind of show you, for example, here is angle 6, which is technically an angle of elevation, because here's the horizontal, and from the tree, we're looking up to the person. Then angle 4 is also an angle of elevation because This person here from this horizontal straight across is looking up at the bird. But then the angle of depression. So the angle of depression, a little different, right? Horizontal line, however, from below. So like, for example, angle 3 is an angle of depression because from the horizontal bird's line of sight, it is looking down at the person. So that is your angle of depression. So notice how even though this line here, this angle of depression is actually above this because you're talking about the relation from the horizontal here. So again, keep that in mind, that angle of depression. So like example here, the air traffic control, the airport sights a plane at an angle of elevation of 41 degrees. So here's our tower, right? The controller. This is the line of sight from the controller looking up to the plane. So this here is your 41 degrees. The pilot reports that the plane's altitude, so the plane's height, is 4,000 feet. So the plane is 4,000 feet in the air. What is the horizontal distance? Horizontal, right here, from the plane to the airport. So you're solving for X. So now looking at the picture, here we go. Do we have the hypotenuse? Here's your right angle. Do we have the hypotenuse? No, nothing here. So that means we use tangent of 41 degrees. That is equal to, here, we're going to set this up. I've got opposite, which is 4,000 feet over X. So now notice, because this is the opposite, we're not going to solve by multiplication. You are going to divide 4,000 by tangent of 41 degrees. So that is, when you practice putting that in the calculator, right? So you've got 4,000 divided by that tangent of 41 degrees, you should get approximately 4,600 and approximately 4,601 feet. So in the next example here, a forest ranger in a 90-foot observation tower sees a fire. The angle of depression, right? So angle of depression is 7 degrees. So that means from the observation tower looking down, right? Now keep in mind, that's not 7 degrees. It's from the line of sight. So this section here is 7 degrees. That means if that angle of depression is 7 degrees, if I wanted to know then what this angle here is, well, that's just another 90 degrees. So that's why this angle here is 83 degrees. Or you could also use the concept of parallel lines because here's our ground. They are parallel to each other. This is our transversal, which means if this angle here is 7 degrees, then this angle here is also 7 degrees because they're alternate interior. So you have options on what to do here with your setup and using an angle. So we'll focus on the 7 degree. What is the horizontal distance? So what is the horizontal distance? This is our X. Now keep in mind, we did have the 90 feet here. So this is our 90. So let's go ahead using 7 degrees. Do we have the hypotenuse? No. So again, we're going to use tangent of 7 degrees is equal to, so here we've got our 90 over X. So again, make sure you are dividing, right? So again, we are dividing 9 by tangent of 7 degrees. And you should get that this is approximately 73